Okay, I'm gonna spend 1 hour trying to do this problem here. I haven't looked any further into it. I probably won't be able to solve it in 1 hour, but I think 1 hour is a good time to test things out and to learn. And then I'm gonna spend half an hour looking at the solution. After that, I'm gonna study some stuff from the Turing. But then I'll probably close the stream and start again. Should do the other stuff from Turing and Kaggle competitions. So I'm put the timer. So this is the same problem from yesterday. We have a 2D matrix. No, we have a matrix and we need to calculate the determinant. Determinant formula. Determinant linear algebra. Blah. AD. So is the diagonals. Multiply and with minus BZ minus CY. BZ minus CY. So is this one. AZ minus CX. Yeah, so the way to remember is you pick one element of each row, and then whatever element you pick, you exclude the column and the row from that element. And then you do the multiplication like this. I guess this is on, oh, you also multiply the ijk. So when you have I, you exclude these ones, bz times then j is this, and k is this. Yeah, this is gonna be extremely difficult. So I don't know if with data product thing I can multiply like that. And then the issue is, what about the determinant of a 4x4 matrix? That sounds really hard. Or maybe I should figure out the 2x2 one first and then think about the rest. So let me think. So it's the diagonals, or I'm gonna calculate the diagonals. So it's the first element of the first one and times the second element of the last. So it's gonna be matrix 0, 0 times matrix 1, 1 minus matrix 0, 1. Yeah. Times matrix 1, 0. So the only thing that is going to be changing is these indexes here, depending on the size. I wonder if maybe I can use NumPy as well to calculate the shape. Just wanna see if I can get the shape of the matrix. Yeah, but okay, one by one. It's saying list index is out of range. That's weird. Maybe I can't access it like this then. It doesn't work. Oh, maybe NumPy has a formula for determinants, probably. Oh yeah, I think I remember that. NumPy determinants. So I don't need to figure out the... Yeah. And I can also do matrix multiplications with NumPy using the at symbol. Let me see if this works. But I don't know if this is considered as cheating or... Because the point is to do it from the ground. Just doing the raw calculations. A one-dimensional array given. Oh, that's why I'm running out of index in the first one. So if there is one-dimensional, then what's the determinant? I think it's one... I'm gonna put a check for the dimensions first. Yeah, shape. And do... But then how do I check? I think continue is just for loops. Determinant of a one-by-one matrix yields the value of the one element. The true value of an array if more than one element is ambiguous. Hmm. You can also use the index to see. Or I can do it on try except block, but it doesn't feel like it's a good way to deal with this. Just let me think about it. And p dot all. Yeah, but it's not what I wanna test. Or maybe it is what I wanna test actually. Can use np dot all equals maybe matrix equals that. Like this. Yeah, but it's still not catching. I guess because I'm using this condition. Oh, actually, I should be using A here instead. That's probably why it's failing there. Hmm. Oh, it's because I'm passing the shape here. That's why. Okay, now I think it's working. Okay, so if it's one dimension, I guess I can just see how to calculate. I'm gonna do that now. Python determinants of array of one-dimensional array. What is the determinants of dimensional array? So matrix of order, there's rows and columns represents every column, for example. The determinant matrix is represents by form. Is the element itself? Yeah, but what if it has more than one element? So the determinant of A is equal to the number that contains the matrix. What if there are multiple values? Which one do I choose? I guess I'm just gonna give the element itself, probably. Return matrix A. Oh, matrix 0. and it's probably gonna pass, but yeah. So now I have to think about the other condition. I think I can do a recursive call to the determinant, calling this depending on the, but then I have to think about the logic. Sure. Hmm. Yeah, I guess I can do always from the first row and eliminate through that, loop through the first row. Uh, and then do a condition for each element of the first row. But the only issue is what is 4 by 4. I think if M is a 4 by 4 matrix with first row ABCD, then then it's gonna be the determinant of yeah, that's gonna be the hard part, because I'm gonna have to think about how to. I think that's the biggest challenge here. How do I call this recursively? And I wonder if I can do bigger than. I guess anything bigger than 2 by 2 should follow the same logic. No, maybe not. Anything bigger than 3 by 3 should follow the logic. Oh, actually, no, because I'm gonna have to figure out regardless. Because if I have a 5 by 5, then I have to shrink it to 4 by 4 and do that recursively. Just seems very hard. But I think the question I have is how to eliminate columns and rows based off on first row. Yeah, but then, because after I do that, I also have to calculate the previous ones. Or maybe not, actually. Yeah, because if I have a 4 by 4, I'm gonna have multiple determinants of the 3 by 3 ones. But if I break them down recursively, it's probably at the bottom. Yeah, it's a tree structure, I think. So I should use a recursive method here, probably. Yeah, because and I should probably have something to memorize the thing. Because at every level is gonna be a tree. And then at the bottom, I'm gonna have all the determinants and the alternating signs. And then each one previous to that is gonna increase the size of the matrix and decrease the size of calculations. So it's a question of how to do that. How to figure out the signs as well. Maybe I should solve it for 3 by 3 one first and then think about the other cases later. Otherwise, I'm gonna spend so much time thinking. So I think I should loop through the first row and then eliminate the other ones based on that. The other issue is that I think I'm gonna have to have multiple conditions for. I need a way to check for the shape of the matrix. Yeah, but Because that's the problem, how I'm gonna get the indexes of each one. I can just call the function actually. So maybe I should put a condition here to check if it's true by true. And then I should put another if statement, another else here. It won't be like this because I'm gonna have multiple of them. In the other case, so the final case has to be the sum of whatever I store in a variable on each iteration. Yeah, I can put a check condition. I can make a variable here called result and make it equal to none as default. Check if it's none or not. And then call with the variable to store the value of the previous iteration. And then I can do the this plus result here at this point. But then the only problem, yeah, then I have to put the condition here as well. Because if they pass it true by true, then it's gonna fail if I don't put the condition here. Alright, then else I can do something else. So the question is, how am I gonna shrink the size of the thing without knowing the dimensions? Maybe the question is, what numbers do I need to preserve on each one? It's very hard. Because more than 3, I also need to... Or maybe it's the same pattern, actually. So it doesn't matter. It's about figuring out the final one, let's say. I can just reduce the matrix by the same logic and pass it into the next call. Yeah, that's... I think I'm gonna put the variable here already. Yeah, but now that's the problem. Oh, actually, I only need to put the condition here. Because that's only gonna matter when it's true by true. So if result equals none, or maybe I can just put if not result. Then I return this. Else results return results plus equals this. And then I can use this variable to store the value on each iteration. So how do I shrink the matrix? I think I need to find a way without explicitly telling saying which elements I should. But that's the thing, let me think. It's not as simple as looping through the first row and eliminating each one, and then maybe it is that simple actually. Because for each matrix, each resulting matrix, I can do the call to the function again. How do I remove the other ones? That's the thing. I need to remove the row and the column without using the index. It's the permutation of the determinants that's the problem. Maybe we can use the products stuff. But I still need to exclude the rows in the column. The row in the column. And here I'm also missing this sign, the permutation on the sign here. So that's the problem. Yeah, this one is very hard. I feel like I should be able to use some NumPy stuff, but I just don't know the methods by memory. There's probably some methods with NumPy that will make this a lot easier. You can also think about doing some other function to handle the logic there. Biggest thing I don't know how to do is how I'm gonna do this stuff without having the indexes, without using the indexes. Because it has to work for any dimension and scale down. Yeah, I don't think I can use a variable. I'm gonna have to use some kind of a object to store the values, and on the last one is gonna be the sum of all of them. So I'm gonna have a store for negative and positives. And I think the signs only matter at the last level. Because up until then, yeah, but that's the thing, you need to preserve somehow, because if you have a 4x4, the determinants of the 3x3, maybe it doesn't matter. Yeah, but yeah, it does matter because you're gonna have more than, you're gonna have four 3x3 determinants. Yeah, so the dimension of the matrix determines the size of the tree and at each level. So if you have a 4x4, then you're gonna have 4 nodes in the second one. And for each node, each one of these nodes, you're gonna have 3 other ones. And then for each one of these trees, you're gonna have other ones. You're gonna have 2. No, you're gonna have 3 determinants at the last level, and it's gonna alternate the signs between them. But how do I do that? That's really hard. Maybe I can look into. The thing is, I don't think depth first search or breadth first search are gonna be useful because they're searching methods and they're not for constructing the tree. I think the challenge is constructing the tree. And once you have the tree, then it's all about getting the results for the next level. But maybe on the recursive function call, I can have. Yeah, I need some sort of way to tell. Because if it's 4x4, I'm gonna have to do the 3x3 ones multiple times. So if I just shrink the size of the array and call the function again, it's not gonna work. But maybe it does actually, because I'm doing line by line. No, but then no, because I'm probably gonna lose the information from the other matrix. So if I do for 4x4 and then I shrink it down to 3x3 and call the function again, then I won't have the determinants for the other 3x3 variations. That's the problem. I need a way to call all permutations. Maybe I can use the iter_tools thing. Because I remember the product, you can pass n amounts. An n amount of time to redo this stuff. But the product is only for, oh, actually, no. It takes 2 arrays and gets all the permutations. So maybe recursive is too complicated. Might be easier to just get all the variations in one time and then call only recurse once when I have all the values and figure out the sum in the other call. Biggest challenge is figuring out how to reduce the size and get the permutations. I can't think about a way to do that still. Because they can't specify any index. That's the problem. Oh, maybe I can use the length of the first list to specify the amount of times that I wanna do this. That sounds interesting. Now the question is, how do I get the 2x2 determinants at the end? That's the thing. And then at the end I can just do... But I think product is not gonna be the best solution. But once I have all the determinants, I can just do this formula here. So I'm thinking about getting the length of this to decide how many times, because the length of this is gonna give me the dimension of the matrix. And then I can use that to determine how many times I'm gonna split the thing. Yeah, but I don't think that works, because if it is 5 by 5, then it just gets more and more. Maybe I can do... I'm gonna try to do with ether products, tier 2 products. Because I probably can just do the product to get all the variations of the 2 remaining matrix. But the only issue is, if I do it like that, I'm gonna get all the variations, and I don't want that. I just want the variations that exclude these ones, and I also have to multiply by the element. So I guess the question is how to remove elements of a matrix using NumPy. What I'm thinking about is removing the elements. I get the length, then I remove the elements for each row, and then call iter2's product for the range, which is the length minus 2, which is the last determinant. And then with that, I can, with all the iterations, yeah, but then the issue is the sign. That's the problem. Hey man, what's up? Commander Trash Thing. I have to figure out a way to calculate the determinant of a matrix, regardless of the dimensions of the matrix. Yes, very difficult. So the 2x2, you can just do this method from NumPy, but then from higher matrices, you can reduce the size. Yeah, it works like this. You reduce the line, you cut out the line in the column for each number, and then you calculate for the determinant for the smaller 2x2 matrix. and multiply by the number that you just picked. So in this case, if you select A, then you cancel this out. Oh, okay. Yeah, but I can't figure out a way to, because from what I'm thinking right now, I can't specify any index because it has to work for any dimension of the matrix. Gauss method, how does it work? I have no idea. What I'm thinking about now is that it works like a tree structure where the dimension of the array determines the top of the tree, and depending on the dimension, it determines the size of the tree. And then you need to get all the values of the bottom level, which are the determinants of 2 by 2, and then you do this calculation here, and you can make a recursive call and store the values of the previous ones in order to calculate the result in the last line. How to triangulate the matrix. And then you just multiply the number on the diagonal. It's much easier. Just need to learn how to triangulate the matrix. Yeah, conceptually it's not that hard, but to translate it into Python, it's very difficult for me. Gas method. I'm probably lacking mathematics as well. Like you said, there's probably a method that makes it easier, which is this Gauss method. Oh yeah, I'll be happy if you do. What should I look for? Gauss methods, NumPy. I also want to be careful so I don't cheat the stuff. Because the point is to learn, obviously. Otherwise, it doesn't make sense doing this. But I think you are allowed to use these methods, probably. I was thinking about using the itertools product, but I'm not sure if it fits very well because you have to eliminate rows and columns, and you also have to specify the sign here to get the variations. So the product is kind of difficult to think about a way. I'm also not experienced enough with the product, with using this product from itertools. Mathematics Gaussian elimination, also known as row reduction, is an algorithm for solving systems of linear equations. It consists of a sequence of operations performed on the corresponding matrix of coefficients. That can also be used to compute the rank of a matrix, the determinant of the matrix, and the inverse of an invertible matrix. That is named Scala, Gauss. Swapping two rows, multiplying a row by a non-zero number. Adding a multiple of one row to another row. Subtraction can be achieved by multiplying one row with -1 and adding the result to another row. Cause be transformed into a number triangular matrix. One that is in row echelon form. I don't know what that is. Once all of the leading coefficients leftmost non-zero entering each row are 1, and every column containing a leading coefficient has zeros elsewhere, the matrix is such a being reduced row echelon form. It's unique, in other words, it is independent of the sequence of row operations used. For example, things are operations where two elementary operations on different rows are done at the first and third steps. Third and fourth matrices are the ones in row echelon form. Okay, so I'm not sure if I'm understanding. It seems a little bit complicated, but I think what it's saying is that you transform the numbers, and then based on that, the multiplications of the matrix is going to reduce the matrix in such a way that You can do the calculation. Pretty easy. Yeah, it's just my first time seeing this, so it's probably gonna take me some time to understand what's going on. Yeah, I do. Do you wanna get in a call? There are three types of no voice and explaining. Yeah, sure. The link to my Discord server is on the down below, and my name there is Flow State, I think. But I'm not sure. I don't know if I probably won't leave your voice to the stream because I don't know what you're gonna say. But I think we can do that. I'm not sure how the voice works as well. Yeah. General. Let me. I have Discord closed. Let me open Discord. I also have some music going on. Hey, can you hear me? I'm not sure if I can hear you. Just a sec. I think I have to adjust the mic here the headset. How do I do that? Voice and video, probably. Output device. Yeah, say something. Yeah, nice. I can hear you now. Yeah. So you take the first row, for example, and then you do what? Yeah. The way that I'm thinking is you eliminate based on the first row, you eliminate the other ones and you reduce the size of the matrix that way until you get to a 2 by 2 matrix, and then you can do the determinant from NumPy. Mm. Let me see. Where are you putting? Oh, the messages. Yeah. I see it. 1, 2, 3, 4. Okay, it's supposed to be a 5 here as well. It's 1, 2, 4, 5, or 1, 2. Yeah, so you're doing 4 minus 6, the first one, and then 6 minus 8 on the other one. Or no. Yeah. I'm showing this to the stream, by the way, just so you know. The conversation. Yeah, because what matters is the final result, right? Is one multiplied by the other and then reduced. Yeah, yeah. No, I understand. Yeah. Yeah, it becomes more challenging to me once is more it's higher dimensional matrix because then it gets confusing how the reduction is gonna work. Yeah, yeah. Oh, it's gonna be zero. Oh, I think I remember now. It's gonna be zero for each column, right? For the row and the column, and then the same matrix. Yeah, yeah, sure. So above the diagonal is gonna be zero, and below is gonna be uh, and then the determinant is gonna be the multiplication or the formula. Ah, interesting. So you're basically saying that I can do a recursive or a loop or something like that until I get to this point where it's only zeros, and then I can do the iter2's product stuff on the remaining numbers? Hmm. Yeah. The only thing that I don't know is how the calculation works, how the formula, because I don't remember really well how it works, matrices. So I guess that you're gonna multiply this by another one in such a way that you reduce the number of columns and rows based on the one that you are selecting. But how are you gonna do that transforming to Python to an algorithm is yeah, and yeah, first priority is just make work, obviously. Then worry about efficiency. I just don't know. I can think of I can try. No, but I can try to understand it. I think maybe the mathematics is better than I can translate it to Python. It's just that I don't think I understand really well. I think I know the overall logic, but I don't understand the specifics. Because are you going to reduce only one time, one row and one column? Because from what I understand, you have to reduce it in every single. For example, you pick the first line, you have to reduce. You gotta get the reduced determinant of the reduced resulting matrix of each one. So in this case, if you pick the element x11, so if you do it in this way that you're talking about with the calculation, you only need to do the reduction once, and then the resulting. So for example, if you have a matrix of dimension 5, you're only gonna reduce it to a matrix of dimension 4, and then do the. Yeah, that's probably the reason why I'm confused. Mm, interesting. Yeah, yeah. I'm seeing the conversation we have here. I think I'm gonna increase the volume of just on. No, 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 no. Increase the volume on OBS so that the stream or the recording of this has your voice. Is that okay with you? Okay. Just have to. Yeah.
Okay,
Now I
so
think.
let me check. Array P3 or something. So this is the matrix. Um, let me check something real quick. Okay, so this is the length, yeah. What we do is we do like, okay, let me define the matrix first. Some matrix that we're gonna use. Matrix.
But so far,
Matrix.
from what I understand, this method sounds a lot better to do than the other one. The other one sounds a lot more complicated because you need to do multiple times and figure out the tree structure. But this way seems like you only need to figure out the calculation once and then you can do the product. So it seems a lot easier.
Yep. Okay, so this is going to be the matrix, and let's fill it with something. Loop for e from 0 to 3. Loop for e for g from 0 to e. This is where it gets maybe a little quirky because of the way Lisp works. Random 10 or something, I don't know. Okay, so we have a matrix. See it? This is the matrix. It's going to be like this. This is the first row, this is the second row, this is the third row, this is the fourth row. Makes sense so far?
Where are you putting this? On the
This is my
okay,
REPL.
the call. Let me see.
This one.
I was watching the conversation, not the call. Okay, now I see.
So this is the matrix.
On the left side
On
is
the
the
right
calculation.
side. Oh, on the left side is going to be the calculation, yeah.
Okay.
Okay,
So I
so
have a
what we
4x4
do-
matrix.
4x4 matrix, and I'm gonna like write it down. So abstract is gonna subtract. Actually, let's call it just add because it's shorter. I'm gonna add with a negative sign.
Let me see if I understand. You're creating a function, passing in a
Called
matrix, row 1 and row 2. What is the optional thing?
It's a coefficient with which I want to add. Because maybe I don't want to add it once, but I want to add it like 4 times or 4.5 times.
Okay.
It's optional, and by default it's 1. And what we do is we say increment AF matrix O1 I. So this element by multiplying the coefficient of a ref matrix O2, same column. Gonna be okay. File, let's check it. Add matrix 0, 1, that's it. Oh shit. Oh, that's because it's on 2 byte below.
That's the result there?
Pretty much. Yeah, that's the result. So what happened, you see, like this, and this are unchanged, but first row changed because I added this row to it. It was 6, 9, 5, 1. Now it's 9, 14, 9, 1. Because I added 3, 5, 4, 0.
Okay.
Okay, now let's try to...
So you're adding the second row to the first one.
Yeah.
And maintaining
I'm just showing you. I'm just showing how it works.
Yeah, just making sure I understand what's going on.
Okay. Triangulate matrix. What we need to do is we need to for each what we need to add. Let me think.
What does below mean?
So below just means like
It's up to the range, but not including?
not inclusive range.
Okay.
Not inclusive, yeah. Let me think. So what we need to do is we need to add okay, let's try to do this. First of all, let's try to matrix 1, 0, minus 1. This reverts it to, oh shit, no. See, I don't understand my own function. I don't understand what it adds where. Okay, let's try to reverse this. Let's try to add, I don't know, like first to 0. No, 0. Okay, what is adding here? So row 1 is increased by row 2. Okay, so I want to increase first by 0. Yeah, and then I want to decrease zeros by first minus 1. Yeah, see, I return it to its original form.
Yeah, I'm not sure if I'm understanding the 0, 1, minus 1
I didn't
thing.
do anything. Minus 1 means that before adding, I multiply everything by minus 1.
Oh, and minus 1 is the coefficient, like I said before. So 0 is the first row and 1 is the second row. and then -1 is the
Yeah.
coefficient.
Yeah. Let me change. I want to change first by zeros with a coefficient of 1/2, -1/2.
And what is this coefficient exactly? It's how many times you wanna...
It's how many times I add or subtract. Well, it depends on the sign.
But what determines that? Is it arbitrary or is...
Well, for now, it's just whatever I input is the coefficient. Whatever
Yeah,
I
but
input here.
I mean to calculate the determinant at the end.
No, wait for the determinant.
Okay,
I'm
okay.
just gonna manually triangulate it first to show
Sure,
you. Okay,
sure.
so now what I did is I added first zeros to the second, so first, the coefficient of -1. What happened is, as you can see, this second row has 0 in the first column. I'm going to do the same and add it to the second with a coefficient of, let me think, what, 7 divided by 6. And I'm going to do the same with the third with a coefficient of -1 divided by 6. See what I did here didn't change the determinant at all, but now the first column is 0. Here it's 0, here it's 0, and here it's 0.
Yeah.
And the rest changed somehow.
I think I
So the
understand
matrix
what you're getting at.
Yeah, so we nullified the first column. Now we need to nullify the second column, but only below this 1/2. We need to nullify this and nullify this. You don't see my cursor, right? Okay, we need to nullify this. You need to nullify this.
Yeah, I see your
Can I do
cursor
that?
actually.
Okay, nice. Okay, I'm gonna do that in a loop. So let me think. So here what we need is to...
You're gonna change the
again.
coefficient every time, so you make all the things
Yeah.
0. Yeah.
From J low array dimension matrix 0 again, because we need a nested loop, because we need to do this for each. Okay, let me think. Yeah, we need to do this for each column, for each row, so we need a nested loop. I'm almost done. I need to just write the right thing, you know. What I need to do is I need to add matrix row. Let me think. So for first row, this is J. Like this. Here it's gonna be like and with the coefficient of which I will think later, but let me just tell it to you. So for each, like, and if I only had a pen and a paper, I could show it to you in a second, but oh well.
Yeah, it's very
I
hard
guess you can have
to...
everything. If this was a 2x2 matrix, we would be done already, because we would nullify the first column and the second was the last column, so we would be done. The coefficient is this.
Yeah, the hardest part for me seems to be the coefficients, because it has to change on each iteration.
Yeah, let me think what the indexes should be. It's something like I, or something like that. Let me think.
Yeah.
So it's like the first iteration, it's 0 and 0. Yeah. So this is like that. This is like 0, 0, and then we go by jy or something like that. I think this is the case. Okay, let's try it. Hope it will work. But you see how short these functions are.
Yeah, so far it seems pretty not easy,
Yeah, I
but
made
sure.
a mistake. I made a mistake. Oh, that's because this needs to also be minus. I subtract. Okay, I fucked up my matrix pretty hard. Let me just fill it again with random values. This will be easier. This seems fine.
What is a ref?
Triangulate. Ref is a reference. It's accessed by. It's like square brackets.
Hmm.
I somehow fucked up a little bit. This is hard, but this is how like short everything's supposed to be. I just fucked up the coefficient that I divide by 0 somewhere.
So then, what's the name of this? Is Gaussian
It's
triangulation?
Gaussian elimination. Gaussian elimination.
Gaussian elimination.
Yeah.
I think I vaguely remember learning about this, but I forgot. But yeah, it seems a lot easier than the other methods I was trying to do.
Let's do this. Let's actually do this. You can like try to read about it or try something else. I'm not saying anything. And I'm gonna try to do this in silence for like 10 minutes. I'm gonna leave the call. Then I'll tell you in chat if I was successful.
I think I'm gonna look for how to find the coefficient because it seems to be the only
The
block here.
the coefficient is really easy. It's like you divide. I can explain it by hand. Like you divide the thing by the thing, so you can subtract it and get 0. It's just that I fucked up the indexes here because I have a hard time like realizing which indexes that should be. That's
Yeah,
it.
it's easier in the concept, but to think about how to make it with programming for me is hard because it seems like you're gonna have to do this for. You need to work on a loop, right, for all the elements. And then if you're gonna do it once, then it has to be the inverse of the elements, which is gonna be 1 minus 1, and then it's gonna be 0. Or maybe I'm not understanding correctly. But then if you're gonna do multiple times, it has to change the value. And that's the part that I still don't understand.
I check for equality to 0. I think. I don't. Maybe I do. I'm not gonna check it, but you should check it. This will just work, please. Yeah, divide 0 by 0. Yeah, okay, I'm just gonna think about it, and I'm gonna tell you in chat if I was successful.
Sure. Thanks for helping, anyway.
Sure, man. I mean, it's not much help, but you're welcome.
No, anything is a bonus for me, man. Just learning. I'm gonna study this stuff, and then I'm gonna see if I can do it as well.
Okay, nice.
I'm probably gonna
the chat.
leave though because I had 1 hour for this and I'm already past. But I'll probably study this and try later. I'm gonna do some other stuff in a little bit, study for Kaggle and stuff like that. But I'll leave this challenge open and I'm probably gonna try it tomorrow or some other day to finish. And I'm gonna study this Gaussian method stuff.
Okay, I followed you just in case.
Yeah, thank you. So talk to you later. Thanks for the help.
See you around.
Yeah, see you. All right, great. Yeah, so like I said, I think I'm gonna go right now because I have, yeah, thank you for the follow, Commander. And I'm gonna take a break, and when I come back, I'm gonna study this stuff for the Turing tests and search for a Kaggle competition to train the other stuff. I was gonna look for the solution, but since he helped me with this, and now I know an easier method, I think I'm gonna study this method and try to do it the next time. And yeah. So see you then. I'm probably gonna come back later today in a few hours to do the Kaggle stuff and the Turing. So yeah, see you.